So we covered the engineering personas problem statement until now. Let's jump right into the next stakeholder here. In this case, it's the pricing operations team.
Now that we put y'all on game, make sure you remember who we are.
I'll just start with a high-level overview of what the pricing operations team is supposed to be doing in a company like this. The role of a pricing ops team is essentially very much important in a company where there's a lot of cost implications. So here, this company being a telecom provider, they directly work with a lot of carriers, and those carriers keep changing pricing frequently, right? And because of that, there is a pricing ops team which ensures that their product catalog, which has the price per unit of their selling price, is always optimized and has a profitable margin. So the unit economics management is something that they own, right? So that the carrier pricing does not affect them adversely. So this is something they have to manage. So how does a pricing ops team actually go about managing such a complex product catalog for a company of that scale is something that let's dive into that.
The role of the pricing ops team is to closely monitor their current pricing for their supplier and compare that with the pricing that they provide to the end customer and ensure that they always have a comfortable margin. Got it. So what are the challenges that they are facing on a daily basis?
So in this case, a pricing ops team, let's take one product, right, and go deep. Let's take, say, an SMS product. Now, how does an SMS product get priced? So what are the different variables in what, right? So one is essentially the number of characters in the SMS. Now, why this is important is because in an SMS channel, one SMS is basically 160 characters, and anything more than that automatically is counted as 2 SMSs and so on, right? So that is very important to track the number of characters. Then we have the delivery status. Now, this is important again because generally the accepted practice is not to charge for unsuccessful SMSs, but there are cases where the status is also unknown. And when it is unknown, it is important to be aware of how many such messages are there, because sometimes there are some carriers which charge for unknown statuses and there are some which don't, and subsequently that is also passed on to their customers' pricing, right? So this is again important. Then comes the actual complexity, which basically makes it hard to manage and operationalize, right? The number of dimensions that are involved when it comes to managing pricing. So first is the country, right? So in an SMS, you are basically dependent on which country you're sending the SMS to, and depending on that particular country, there will be different pricing, right? So there are like 200 countries in the world, so each country will have its own pricing. Then we have the network, right? So the network is basically the telecom carrier. So most of these companies use the local domestic carrier to be routing the SMS forward, and that automatically plays a role in what is determining what the price point is. Then we have the operator. So if you look at it, and this is only for SMS, you will find the same thing for, say, an MMS, right? So you will have SMS, MMS, and so on, multiple products. And a combination of country, network, and operator is what determines the price point.
So it is not just the multi-dimensional aspect of it, it is also the cardinality of each and every dimension that brings in a new dimension to the complexity.
Exactly, yeah. So you can easily have like 200 countries, 50 networks, and another, 5 operators per network, right? So you have to basically multiply all of these, and you end up having like 50,000 price points, right, when you have to manage one particular product.
So are these 50,000 price points fixed, or are there fallback mechanism to say if suddenly a new operator is receiving the request and we have not configured a price point for it? How do we manage that?
Yeah, exactly. So I think the operational aspect is very important here, because you cannot be monitoring 50,000 price points, right? It's just physically impossible to do that. So because of that, what the company's requirement or how they manage this was have a hierarchy in place, right? So when I said, country, network, operator, now if it actually follows a tree structure, right? So in fact, you can actually see it like this. We have country, which is, or in fact the product itself, right, which is the top node, right? And then you have country, and then within country you have network, and within network you have operator. So what this means is, this hierarchy, what this results in happening is, if there is no price point associated with the bottommost leaf, it automatically assumes the price point of the previous branch, right? So that's how it works.
Got it. So we talked about the fallback mechanisms that we have today, but in most cases, the addition and removal of operators, networks are all a pre-planned activities, right? So should we bring in capabilities to manage that as well?
So we do have something here, a requirement called a schedule. So for every combination in this hierarchy, they would want to manage a schedule for each price point and also be able to say that in advance, right? So for the next, say 60 days, this is the price for this particular combination of country network operator, and beyond that it is a different price point.
So basically in this tree we are adding a new dimension of time.
Yes. So I guess this is pretty complex in terms of operational management, right? So how do we go about solving this using Toggle?
We have something called as pricing catalog, which is predominantly developed when there is huge cardinality on the dimension. If let's say you have a payments provider, the dimension of payment type is going to be handful. But as you mentioned here, the country dimension itself is 200, which in itself is pretty unmanageable. But when you multiply it by multiple dimensions, it grows exponentially. Maybe adding another factor if later on they want to charge by it, it is not going to be possible in a user experience manner. We have brought in this catalog feature where the pricing catalog can be managed based on the dimensions of an event. Here, let us take the same example of SMS, where the dimensions are country, list of countries, and here you can have networks. Let us take these two as the first example and explain how our pricing catalog is set up.
Yep.
There are cases where all networks will be available in all countries. Though theoretically it is possible, that is not the use case for them. That is predominantly a use case for infrastructure companies where they have same type of instance, same service which is provided in multi-region.
Can you give an example of that?
For example, we can take AWS EC2 instances. So let's say they have EC2 instance of type T3A, and there are multiple sizes: small, medium, large, X large, and so on. So for each and every instance type, there is a different price on each and every region. US East, there is a different region. US West, there is a different region. EU, there is a different region and price, right? So this is going to be huge when you add another dimension. Like say T3A is one. Let's say they have memory optimized M type instances. That is another factor to be considered, and the table grows exponentially. But in this use case, this n cross whatever dimension is not the need here, since they have clearly defined that country is something which is going to have only a set of networks. Another country is going to have another set of networks. These networks need not be present across all countries.
Yeah.
So this essentially separates the matrix model and tree model of the pricing catalog that we provide.
Got it. So essentially the catalog itself can have two types. One is basically meant for solving this kind of a tree structure which has hierarchy, and not every leaf node has a price unit, whereas the matrix model is essentially n cross n cross or m cross m cross, how many ever dimensions are there. Every entry will have a separate price unit.
Correct.
Got it.
Every entry is mandatory. Here it is optional, and you can fall back to either your sibling or your parent or your grandparent and so on.
Got it.
Since the huge quantum of configuration is key here, we have to understand how it is supposed to be configured. Since upfront we have defined that this is an operational problem, we cannot automate it with APIs, because developers' bandwidth is not something that will be spent on these kind of rate management. So typically in your experience, how do you manage these kind of rate cards?
So in my experience, I've seen a lot of companies use Excel, because Excel supports, that's where anybody starts using pricing models for, right? And when you have like 50,000 records, yeah, you can use Excel or any other such tool to just have manual entries and keep editing them. But again, that's a very tedious and manual and error-prone process, which is not something that any company wants to do, but is forced to do rather.
They are already maintaining these kind of rate cards in Excel. They can simply use our CSV import capability, where they have to just for the very first time generate a CSV out of the export Excel file and import it into our system, wherein we can parse that file and understand what is the country subset of network and the subset of operators under that network, and plot the corresponding rates that they have configured. So we can build this tree very easily from the CSV file that they give.
So this is essentially not a a developer-facing functionality like the previous one. But what you're saying is an ops team is going to be managing something using CSV or an Excel file, and we provide a file-based model as well for managing their price points.
Let's say there is a wide branch of tree. For example, a country is undergoing some change, and all the operators, all the networks in the country is bumping up their price. So it is going to be very difficult for ops person to come into any system and update. If those details are available in Excel, the updates can also be imported directly.
For example, you want to do a very large bulk upload based process, right?
Correct.
What do we do? Say, for example, there is only one operator or one network, right, where I want to go and change the pricing, or one specific country.
We can use the search functionality that we have for filtering the tree. Basically, traversing the tree is going to be complex for so many countries, so many networks and operators, right? So we can use the search bar on top of the pricing catalog to just do a full text search on the network name or the operator or the country. So that will just focus on that branch of the tree, and you can drill down and keep searching until you find the desired branch or the leaf node of the tree.
How do we schedule price changes in advance, or how do I manage that timeline for every price point that I have?
As I mentioned, you can traverse and get to a leaf node of a pricing catalog tree. There we have the capability to assign the default price for that particular node. So the default price is, by the very first time you configure, is essentially from start of time to end of time, right? But when you have to apply a pricing change, you can specify from when that new pricing is supposed to happen. So thereby bringing in a schedule of default rate for each and every leaf node. The schedule of rate is not only managed at the end leaf node, it can also be managed at the parents and grandparents as well. This provides the ability to manage fallbacks if required, and the fallbacks can also be scheduled in the appropriate manner.
Got it. So essentially, if I'm looking at modeling this as a timeline, right? So what you're saying is we have, say, a timeline for the top branch, which is, say, the product itself. Then we have a timeline for the country, for each country. Then we have a timeline for the network. And then there is an operator level timeline, right? And when a pricing is chosen, the first check happens for a particular time window, say 1, 2, 3, 4. So for a particular day, you take a price point when, say, an event comes from this operator. You see if this operator has a price here.
Correct.
If there is no price here, then you go up traverse and see if corresponding network has a price, and then so on.
We keep going up till we get the value.
So there will be a default price which has to be configured no matter what for the product.
Correct. That is the only mandate that we have, because there is a fallback mechanism for a created product catalog. There has to be a default price.
Understood. And this is something we can create multiple catalogs to manage multiple products for. Is that the
correct? You can create as many catalogs as you want, and those catalogs can be subscribed by an account.
So this kind of makes it very simple and easy to use for an ops team to configure and manage all of this complex 50,000 odd price points in a simple to use interface. That wraps it up for the pricing ops teams.